once they collect the data, and it's their interpretation of it that is actually collected, not the actual raw data. So it cannot be post analyzed a second time or with modern technique. So what we are proposing is the cleaning we saw earlier, which is cavitation cleaning. It has a higher speed than manual cleaning. Those are just numbers to give you an idea. It can also be doubled because we can just put two machines side by side, so the speed can be increased just by scaling the unit. The geometric survey is 1 millimeter accuracy. It's can be exported to CAD software, which obviously divers can't do. The steel thickness is an array of 3 sensors, so they have a continuous scan of the steel rather than a point every so often that the divers are doing. And the delamination is also as all the data exported for post-processing. It has a reliable armor strike because it's motor driven. And we do also capture video while we're at it for surface appraisal. So the trolley that we developed for the delamination detection consists of just an hammer that strike from going a full circle, half circle actually, 30 centimeter apart. It does have speed. It's not very important. The suction, it has a suction cup that's allowed to go in turbulent water, so it stays in place and it's not affected by the current. And it has a configurable speed impact speed adjustable beyond 3 meters per second for the impact speed. The concrete start to just getting damage, and it has the hydrophone used and the signal conditioner for post-processing the data collected. So we did all the validation for the trolley in pool that we have at our facility on blocks that were manufactured with pre-defect during manufacturing, and we were able to detect using our software on the right side all the defect that were embedded in the concrete, except for the last one because the defect was too deep into the concrete. But we do have hope that by changing the processing of the data, we'll be able to actually have more information about the defect over there. So this used the simplest technique possible to detect the defect, which is just the amount of energy in the signal captured. So there's no like filtering or fusion of different algorithm for the data at this point. So the case study was on Lagabelle spillway. We see here they have a cleaning trolley, which is doubled over there. So there's two mounted side by side, so it can actually does the cleaning faster. And the objective was to inspect the area pointed by the arrows so that they could sit the coffin at those points and be sure that it will hold while the other side is being dried and workers are doing reflection on the other side. So the result, we did a geometric survey of the area. It gives us a 3D map of the surface, and we do also have a vertical deviation from left to right. So they knew that when they manufactured the coffin, exactly what to expect in terms of a vertical readiness of the system and where the cracks are so that they can have the coffin properly sit and hold the water dry. And as for concrete delamination, it's also important for safety of people on the other side so that there's not a chunk of concrete that would just rip off while the coffin is sit there. The left side is what has been presented in the paper. It's hard to see if there's delamination or not, because this is the raw signal. It has not been filtered on anything. And between the publication and of the paper and now, we did work on filtering the sound and actually getting more filtering the information that's not relevant from the signal. And so we did have a map that shows that there's a little something on the top, which was already also surveyed by the 3D scanner. And because the size of it is not big enough, they're probably not going to do anything about it, which has been confirmed by divers. They went over there a month after we passed, and they found the same crack and no delamination on the concrete, which pretty much validate that our system increased the confidence in our system. We do have a few recommendations. We're short on time, but yeah, pretty much it's improving the signal, maybe using a ROV for changing the scanning method would be nice. And if you do have any question, we can contact either me or the project manager over there. And there's also quite old website about the robotic we do at Hydro-Québec. So I'll be taking questions.